and then 5 moles of nitrogen, and a total pressure of 1000 torr. Calculate the partial pressure of each gas. Okay, so we're given the moles of oxygen, argon, 2 moles, and then oxygen, 3 moles, then nitrogen, 5 moles, and pressure total is 1000 torr. Okay, so we get the total number of moles here. To get the partial pressure using Dalton's law, partial pressure, that is the mole ratio, mole fractions times the total pressure. I'll just put P sub of T for total pressure. Okay, and then for the mole fraction, that is the number of moles of each of the components or elements or whatever there is divided by the total number of moles. Okay, so we get the total number of moles here. So N total is just 2 plus 3 plus 5, and that is 10 moles, and then the mole fraction for each one. So mole fraction of argon is equal to 2 over 10. Mole fraction of oxygen is 3 over 10. Then mole fraction of N2 is equal to 5 over 10. 2 over 10 is 0.2. This is 0.3. And this is 0.5. Now we can solve for the partial pressure of each one. So partial pressure of argon is just equal to the mole fraction, 0.2 times 1000. Then partial pressure of oxygen is 0.3 times 1000. Then partial pressure of nitrogen is 0.5 times 1000. Yeah, so 0.2 times 1000, that's 200 torr. 0.3 is 300, 500. Okay, so those are the partial pressures of each of the gases given. Got that? 56 grams of N2 and 96 grams of oxygen are mixed in a 2-liter container at 300 Kelvin. Calculate the partial pressure of each gas and the total pressure. Okay, so this is what we're going to do since we're given the masses. So mass of, so are they given? Mass of nitrogen is 56 grams, and then mass of oxygen is 96 grams. In calculating the partial pressure, we need the mole fraction or the number of moles. So we need to convert this to moles. You multiply this or divide this by the molar mass. What's the molar mass of nitrogen? Okay, but there are 2 nitrogens there, so this is 28. Yeah, so that would be 1 mole of nitrogen per 28 grams of nitrogen. And then how about oxygen? What's the molar mass? 16 times 2, that is, so 1 mole of oxygen per 32 grams of oxygen. Now let's calculate this. So grams cancel out. This is grams. And we'll be left with mole. So 56 divided by 28, that is 2, right? Then 96 divided 32, that is 3. Okay, the next thing we do, okay, we already have the number of moles, but we're also given the temperature, right? So maybe we can use the ideal gas law. To find the pressure. Yeah, we're given the volume. So we're given the volume and we're given the temperature. So maybe we use the ideal gas law. PV equals nRT. And we find the pressure. So that is nRT over V. Yeah. So the ideal gas constant that we're going to use, because this is in liter and in Kelvin, so we use this 0.0821 or 206. What's this? Liter atmosphere, mole per Kelvin. What's the unit? Because we are given liter and Kelvin and pressure, so we don't use joules, so we use 0.08 liter atmosphere mole Kelvin. Okay, remember that? Should remember that one. There are two values for ideal gas constant. The other one is 8.314 joules per mole Kelvin. That is for SI units. The other one is this one, 0.08206. Okay, then let's solve the partial pressure of each one. We use this one. So partial pressure of nitrogen, this is 2 moles. Okay, 2 moles N R 0.08206 liter atmosphere mole Kelvin times 300 Kelvin divided by the volume, 2 liters. We'll make sure we cancel the units. Mole cancels out, liter and Kelvin, so we're left with ATM. So our pressure's unit is atmosphere. So what is that? 2.0. Can you solve that? 2 times 0.0. Okay, 2 cancels out because 2 divided by 2 is 1. So you will just have to multiply 300 times 0.08206. You got 6.18. We'll try to calculate on the. Maybe I made a mistake. It's not 2. Yeah, it's 24. 24.6 atmosphere, and then the pressure, partial pressure for oxygen, this is 3 times 0.08206 times 300 divided by 2. What did you get? Okay, so this is 36.9 ATM. So those are the partial pressures of each of the gases. And now we can solve for the total pressure. I'll just write here. Total pressure is equal to 24.6 plus 36.9. So the total pressure is, what's that, 9, 15, 10, 11, 60, 61, 61.5 atmosphere. So that is the total pressure, and this one are the partial pressures. All right. What do you mean 1 mole of everything? How do I know how do we know how many moles there are? We use the formula. We don't know. We didn't know. We were asked for the mole fraction. We don't know the number of moles. We're not given the number of moles. And we don't need it here because we're already given the partial pressure. Are you confused? All you have to do is just, use the formula. This is the formula for mole fraction, denoted by chi, this one. Yeah. So you don't need the number of moles there. Maybe you were confused of the previous problem, right? A container is filled with nitrogen, oxygen, and argon gas. The partial pressures of N2 and O2 are 615 and 125 respectively. If the total pressure is 785 torr, what is the partial pressure of argon? So we're given here the partial pressures of nitrogen and oxygen. It's 615 torr, and then oxygen is 125 torr, and total pressure is 785 torr. So total pressure, you just add up all of the pressures, partial pressures, oxygen, argon. So partial pressure of argon is just equal to the total pressure minus pressure of nitrogen minus the partial pressure of oxygen. So this is just 785 minus 615 minus 125. So what is that? 7, 10, 3, 730, 740. 785 minus 740. 10. 785 minus 740, because 615 plus 125 is 740. Yes, so it's 45 torr. So this is the partial pressure of argon. Okay, a 2 liter, a 2 liter vessel holds 3 moles of N2 and 2 moles of O2. So we're given here the number of moles of N2, which is 3 moles, and then number of moles of O2, which is 2 moles, and the volume, which is 2.0 liter. we need the mole fraction. So we get the total number of moles first. Total number of moles is 3 plus 2, so this is 5 moles. And then to solve for the mole fraction of each of the gases, so mole fraction of N2, that is number of moles of N2 divided by the total number of moles, so that is 3 over 5. Then the mole fraction of oxygen, that is the number of moles of oxygen divided by the total number of moles, that is 2 over 5. Then next one, if the total pressure of the container, so we're given the total pressure, which is 1000 torr. What are the partial pressures? Okay. In calculating the mole fraction, that is just the partial pressure of the gas divided by the total pressure, right? So we're given here the mole fraction and the total pressure, so we can solve for the partial pressure of each of the gases. So partial pressure of nitrogen, okay, what is this one? 3 over 5, 3/5. Okay, 0.6. And the other one, 2 over 5, is 0.4. Okay. So the partial pressure is just the mole fraction of N2 times the total pressure. So that is 0.6 times, what's the total pressure? 1000. Then partial pressure of oxygen is the the mole fraction of oxygen times the total pressure. So this is 0.4 times 1000 torr. Okay, so let's calculate this. Partial pressure of N2. Okay, 600 torr, and this one is 400 torr. Okay, so in this case the volume is not used. Yeah, not useful in this calculation. So did we get it right? The same as what you have there?